my question was if what you were talking about before, this thing about we need to agree on certain things on a certain level. Um, if we again take our body as an example, you have a liver. There are, I don't know how many different cells in the liver which are specialized in doing stuff, but those cells who are specialized in being the skin of the liver, so to say, they agree on that, right? And then you have people or cells, I call them people, that make up the whole liver, right? And they have agreed on certain sets and rules and organization on a liver level. And then you have humans. I have so many trillion of cells. They mostly agree on how to work together. Sometimes, if we see cancer, it's because we have some cells who doesn't agree any longer with how the main system is working. Uh, and then we have humans working together in a smaller group and a bigger group and a bigger society. And would that be a way of to what degree do we need to level on certain things, depending on what scale we are talking? I would leave that to you. That was how I understood your chart. So correct me
Mm.
if there's something about that.
I think the answer is yes, very simply. And the chart then becomes like, what is going on in that situation? Let's, for simplicity, just stay with biology without the nervous system for a moment, because I think that is where it all gets a little bit complicated in ARI. But like, we could look at an organ, for instance, like the liver that you mentioned, and go down those list of characteristics and essentially like tick off everyone and see and sort of describe, well, how is it doing that thing, or where is that thing in the liver? Such as, what is its function? Like it is all as a bunch of cells working together to perform a function. It has a clear boundary around it, but then, if you want to get pedantic, we might go, well, where does the liver end and where does it start? But that's kind of missing the point. The point is more that it is an organ that has what we can, as a human, call an arbitrary boundary that we come up with as an observer of the kidney. But for all intents and purposes, as a functional unit, it does have a boundary around it, and that boundary is made by itself, and itself is made by itself, and it is receiving energy so that it has something to metabolize, to put to work in service of all of the specific functions it's doing. And then it is housed within the human body, so it is within an environment, and that environment includes many things that it is independently noticing, selecting for, and responding to, so on and so forth. So in essence, yes, that is a good example, a way to think about what the chart is trying to incorporate. And then the extension, if we sort of then make the massive leap into trying to apply it to a system that we have created as humans out of our abstract nervous system, we can create things that don't honor those principles. We can we can create money which allows for interactions between people in very different places, and we can create information systems or technology that enable that. But when we do that, we're more operating in the abstract space rather than the biological space. In the abstract space, unless we're very careful about how we manifest it and how it evolves, it's very unlikely to honor those same principles. And it's by my estimation, very unlikely for it to be as alive as it could be, or maybe more importantly, to be interacting with other parts of ecology in ways that are healthy for, there's basically two levels in the world. There's the self and everything else. And at all times, we kind of need to be tending to both pieces. We need to be tending to our aliveness, but we need to be also tending to the aliveness or the life supportingness of the environment that we're in. And what abstraction has the magical power to do, and human systems have the magical power to do, is in the short term for us to really only tend to one part of that that puzzle. And